Good afternoon. Welcome to homework problem 9.11. I have the drawing up on the board already. Problem statement is calculate the centroid of the given figure. So this will be calculating the centroid of a composite figure. And when I see this shape or this composite figure, I see three shapes. So I see a rectangle that is 3 inches by 2.4 inches. I see a triangle and I see a semicircle. So I'm going to, my approach is going to be, my plan anyway, is I'm going to look at three shapes. So I'm going to look at the rectangle. I'm going to look at the triangle. And I'm going to look at the semicircle. So it's an addition and a subtraction problem for me. It'll be the rectangle will be addition. I'll subtract the semicircle and add the triangle. So you might recall the technique that we're going to use. We need to get the area of each of the shapes, so we'll start with that. Area of a rectangle, length times width. So 2.4 inches times 3 inches. And I did this last night and it came out to be 7.2 square inches. So we will assume it will also come out to be like that today. Area of a triangle, 1/2 times the base, 1.5 inches, times the height of the triangle, which is 2.4 inches. And that comes out to be essentially 1.5 times 1.2. 1.8 square inches. And then a semicircle would be 1/2 times the pi times the radius squared. Oh, we need the radius, don't we? Put that in here real quick. And the radius is equal to 0.9 inches. So 1/2 times pi times this radius squared. And the 1/2 comes from the fact that it's a semicircle. So pi r squared is the area of a circle, semicircle is half of that. And if you do this arithmetic or the multiplication, I use 3.14 for pi. I get 1.2717 square inches. Okay. All right. So you may recall from your previous, I'm sorry, I'm going to go back and number these. You may recall from your previous work that a table is an excellent way to go about our arithmetic. So that'll be what I'm going to use as well. So we need the area of each shape. There are 3 of them. So the area one, shape 1 is the rectangle, my shape 2 is the triangle, my shape 3 is the semicircle. So area of shape 1 is 7.2 square inches. We got that a couple seconds ago. 1.8 square inches for the area of the triangle. And I'm going to use negative 1.2712 square inches, the negative being from the subtraction that we have to do. All right, lowercase x bar. So this is the x component of the centroid of each individual shape. So the x bar for a rectangle is 1/2 the x dimension, so 1.5 inches. Y bar for the rectangle is 1/2 the y dimension, 1.2. Let me put my units in here. And you are absolutely correct. I'm sure that someone is saying to themselves right now, hey, Rick, you forgot to put the x and y axis. So I'll do that real quick. Thank you for reminding me. Oops. Nope. Oh, it disappeared. Try again. There we go. All right. Again, thanks for reminding me. And back. All right. So the circle. So for a semicircle, the x component is 1/2 the diameter, so that's the radius. So we need to go from the origin along the x-axis to get to that, and that is 1.5 inches. And then our y component, so we have to get up. We're going all the way to the top this time. Looking at the centroid for a semicircle, let me draw it over here. Please be nice about my drawing. So here's a perfectly drawn semicircle. Not really. That's a little bit closer. And of course, I'm looking at table A1, the area and centroid of simple shapes. And it's given as, the y bar is given as 4 times the radius over 3 times pi. And it's measured from the diameter side, right? So it's measured, y bar is measured, if you're looking at the board real quick, is this distance right here. It's measured from the diameter side. So for us, that means we're going to go all the way to, rather than go from the x-axis up to the bottom of the semicircle and then try to figure out where that is, it would be easier for us to go 2.4 minus 4 times the radius, 0.9 inches, over 3 pi. So in other words, go all the way to the diameter of the circle and then subtract the 4r3 pi. Okay, so that's kind of the approach that I took for what it's worth. And if you do that, you get 2.018 inches. I'm gonna put it down here. 2.018 inches. Okay. All right, triangle. Triangle, well, so that's kind of the triangle is, looking at our chart, is the base divided by 3. So it's 3 inches plus 1.5 over 3. 3 inches plus 1.5 over 3. And that's equal to 3.5 inches. And then the y bar for the triangle is height divided by 3. So 2.4 inches divided by 3, which is 0.8 inches. All right. From here, you might recall multiplication and addition. We love that. All right, so a times x bar, area times y bar. So a times x bar for shape 1 is 7.2 inches squared times 1.2 inches, 10-inch cubic or cubed, and then 7.2 times 1.2, 8.64 for a bar. For the rectangle, 1.8 times 3.5. Hold on one second. Be right back. I got to pause. All right, sorry about that, I'm back. All right, A times X bar for the triangle is 1.8 times 3.5, which is 6.3 cubic inches. And A times Y bar, 1.8 times 0.8, 4 cubic inches. All right, so for shape 3, the semicircle, they will be negative because we're going to subtract those out. So I'm certainly not saying that the area is negative as much as I'm saying the approach that we're taking is subtracting that away from the composite shape because it is not there. Right. Summation of the area, 7.728 square inches. So 7.2 plus 1.8 is 9, 9 minus 1.2717. Summation of A times X bar, 15, 19, 24. And summation of A times Y bar, 7.514 cubic inches. All right, so that allows us to complete the chart. So there were only 2 more calculations, right? So we're looking for capital X bar and capital Y bar, which corresponds to the centroid of the composite figure. So I'm sure you guys and gals remember capital X bar, of course, is the summation of A X bar divided by the summation of area. So 15,1924 cubic inches divided by 7.728 square inches. And I get 1.97 inches. And then capital Y bar, the Y component of the composite, Y component of the centroid of the composite shape is summation of A Y bar divided by summation of the area. 7.514 cubic inches divided by 7.728 square inches. Numerator is bigger. If you didn't notice, the numerator on this one is smaller than the denominator, so we should get a number less than 0. And in fact, we do. We get 0.97 inches. Okay, so our last responsibility is to find that or label that on our drawing, right? So let's see, 1.97 inches. So it's over a half. So this is 1.5 right here. The radius is 0.9. That would be 2.4. So it's somewhere between the center of the circle and the outer edge of the circle. I'm just going to call it right here. Somewhere on this line. So let me change color so we can maybe have a better discussion about that. So it's somewhere approximately on this line, right? So somewhere between 1.5 and 2.4. And we have to go up almost a full inch, 0.97 inches. So let's see, from the x-axis to the bottom of the circle is 2.4 minus 0.9. So that's 1.5. 1.5, so about 2/3 of the way up. So we'll call it right here. And that's where our capital X bar, capital Y bar is 1.97 inches, 0.97 inches. All right, so if we had this figure, that would be, hypothetically the balance point. So, all right, well, I'm gonna pause the video and get set up for the next problem. Well, I'm gonna stop the video, get set up for the next problem. I'll be right back.